Data Analysis Part 8. Common Sense Reduced to Mathematics. Hello everyone, welcome to Part 8 of this data analysis course. This video is skippable. That's because at the moment there's an assignment which is just coming up to be finished off in this course. So we've already covered in the previous 7 videos all the material needed for that assignment. So in this video, here's some gentle background information on something I very much enjoy, which is some history on the development of probability theory by this guy, Pierre-Simon, the Marquis de Laplace, or just the legendary French mathematician and physicist Laplace. We're going to look at that. I will very briefly finish off a couple of comments first about regression to the mean as discussed by Daniel Kahneman, since there's a famous quote from him, or a famous example problem from him about it. And then I will talk for some stuff which will not be required for the course, so it's not examinable in any way. I will talk about Laplace's philosophical essay on probability, which is for many reasons, it's a great resource if you want to know more about what probability theory and learning means without getting bogged down in all the 20th century detail which overcomplicates it. So there's this great book. We'll talk through its history. Right. Now I need to switch presentation to look at Kahneman. Right. So we talked last time about regression to the mean, or the regression effect. Mathematically, it was defined as follows. So for two correlated measurements, x and y, of the same type, maybe of the same thing, when, or maybe not, when x is larger or smaller than its mean, y tends to be less extreme than x. And we said, how can we identify if the regression effect exists in data? Well, to show the regression effect exists when y is positively correlated with x, you plot y minus x on the y-axis against x on the x-axis and show that those are negatively correlated. We talked about how you might do that given some light blue data points which had been generated as true values plus random error on 2 measurements. We showed that the values, well, it was necessarily the case that the most extreme values on your first measurement likely contained an unusually large positive random error, and so it was highly probable that they would have a lower second value. If you plot the recommended graph, you should get this demonstration that plotting y minus x against x, you see that that's a demonstration that regression exists. Okay, what does this mean in practice? Well, to put this in a particular example, when we have some phenomena which a large amount of the result is random. So, for example, you might consider that a sports person, some of their performance is down to a consistent amount of skill that they always have, plus some amount in each game is a random amount on top of that. And so, if you believe in that as a description of how the performance in a sports game happens, then, for example, a sports person who has several unusually bad games, well, after an unusually bad game, if the random element of their performance was a negative contribution, maybe it was one of their 10% worst negative contributions, there is, by definition, in the data generating model we've described, there's a 90% chance that their next performance will be better. So, regardless of whether or not a very bad performance inspires a sports person to do something, like a snooker player buying a new cue, in the description of how performance works that we've just introduced, there was a 90% chance they were going to improve in their next game anyway, regardless of whether even if the new cue or the change which they implemented had no effect on their performance. You can't rule out the possibility that it does actually have a positive effect on the sportsperson's performance. But regression to the mean in the psychology of training and sports and management of people has this important story, which was identified by the famous-ish psychology and data analyst Daniel Kahneman. So he was teaching a course on the psychology of training, and this happened to be to aircraft flight instructors. And Daniel Kahneman cited some studies in animals which showed that if you're trying to teach your animal something, rewards work pretty well and punishment does not work so well. So Kahneman recommended that in training, rewards were a good way to improve performance, and that shouting at people doesn't help. One of the flight instructors that Daniel Kahneman was explaining this to complained bitterly, and I can 100% imagine that a flight instructor probably would think this way. The flight instructor said, I have often praised people warmly for beautifully executed manoeuvres, but the next time they almost always do worse. You see, that's regression to the mean. The unusually good manoeuvre probably contained a large beneficial and a rare beneficial random element. It's very unlikely that was going to be repeated. The flight instructor said that he's praised people warmly for this, but the next time they almost always do worse. And, I have screamed at people for badly executed manoeuvres, and they generally do improve the next time. So don't tell me that rewards work and punishment does not. My experience contradicts it. And the other flight instructors agreed. Those flight instructors had no concept of regression to the mean, or at least they were not willing to accept the fact that the performance of the skill they were teaching involved a skill element, but also a large random element in how well things happen. They simply weren't willing to accept that, or they hadn't thought about it. Probably they hadn't thought about it. Probably they weren't very happy to accept it either. If they had, then they would realise that they were wasting their breath yelling at people to the extent that the performance variation was just largely random. And they would have been well advised, perhaps, to be nicer to their students. And this phenomenon, by the way, is also true of in university teaching. You should be nice to your students, and in management, you should not assume that when some manager yells at people and their performance improves, that the yelling at the people was a particularly beneficial intervention. That's the word I was looking for. Now, right, that brings me back to my title slide from a much earlier video on the placebo effect in canine epilepsy drug trials. Now, as I mentioned earlier in this lecture course, the two biggest hazards which I see in interpretation of scientific data are, first of all, Simpsons paradox, when the correlation between what you think it is changing and some consequence is actually caused by some other thing which is causing the change of what you imagine is an independent variable and the outcome. So, for example, does medicine make men sick? Well, it's the fact that people who are already very sick take medicine, and therefore it's not surprising that even if the medicine is quite effective, their health is still worse than average. Simpsons paradox is, so in all of my career listening to scientific talks, half or more of the questions I've asked are you sure that some form of Simpsons paradox hasn't affected your results? A good number of the other questions that I've ever wanted to ask are you sure that some regression to the mean isn't causing your apparent observation? And this particular one, the placebo effect in canine epilepsy trials, is an example of a so-called research effect, or a so-called effect found by some research paper, which almost certainly is a pure example of regression to the mean happening. Let's find the paper for this. Let's find this on the internet so that you don't think I've made this up. Right, so let's follow the link. Here is a published paper, if the link opens up, in the Journal of Veterinary Internal Medicine. And I would like the full text of this if I can get it. Let's have the PDF. This is a published paper, and I mean, a warning in advance. I don't think this is a well designed research paper, and I think the conclusion which they wanted to make was wrong. If you read through the paper in detail, you can find that it's pretty obvious, reading between the lines, that a paragraph has been inserted saying this effect is entirely regression to the mean. And the reason this paragraph's been put in is because some reviewers have shredded it, and they've said this is a garbage paper, and the editor has told the authors, well, you have to include this paragraph to say that probably the effect you're seeing is regression to the mean, and the authors have done that, but they haven't really changed the conclusions in their heading and abstract section to reflect the fact that they probably haven't found anything at all. So it's not a great paper, in my opinion. That said, the introduction is nicely written, and the description of the placebo effect is just quite fun to discuss. So these guys say, background. At least medicine papers, it's easy to read the background. The placebo effect is a well-recognised phenomenon in human medicine. In contrast, little information exists on the effect of placebo administration in animals, in veterinary patients. Oh, God. Hypothesis? Non-pharmacologic therapeutic effects, they say, play a role in the response observed in canine epilepsy trials. Oh, yeah. No. Spoilers, it's regression to the mean. Conclusions, they come up with a positive response to a placebo drug, manifesting as a decrease in seizure frequency, can be observed in epileptic dogs. Why is this going to be regression to the mean? Well, because the dogs were only enrolled in the trials because they were having an unusually bad time of it. And epilepsy being a sporadic variable disease, it so happened that the way this study was done, even though it looks like there are control groups where one set of dogs are given a drug and the others are given a placebo, in the case of the ones being given looking at drug treatments, actually both of them improved, simply because the dogs were enrolled by their owners and their vets, and the only reason they were imagined that they should enroll their dogs is because they were very ill, and they thought they'd try something. Well, as it happened, both the drugs and the placebo, the non-drug treatment, they were given, and then there was some improvement following that. But that's largely regression to the mean, as is described by a paragraph inserted clearly in response to the reviewers demanding it go in. But although that paragraph vitiates, removes all meaning from the rest of the paper, they still published it. Well, fair enough. It's not terribly written. I just disagree with the conclusion. I've described what's going on. Let's just read the introduction, because it's quite amusing to read about the placebo effect. The placebo effect is well recognised. It is, but poorly understood phenomenon. It's not that poorly understood, which involves a non-specific psychological or physiological therapeutic effect, they say, of a medical intervention that lacks specific activity for the condition being treated. Sometimes I think it also refers to phenomena like regression to the mean, giving you an apparent improvement which isn't caused by an effective chemical treatment. Sometimes I think placebo effect means that. Most commonly, I think it does mean you tell people they're being given a marvellous pill and they feel so much better, their health actually improves because of the psychological benefit of being told you're in good hands. And you may come across the, I think, Ig Nobel Prize winning research which showed that expensive placebos work better than cheap placebos. That is, people's health improves even more when they're told the placebo drug, the sugar-coated pill that doesn't actually contain anything, is really expensive. They think that's better than if they're told it's cheap. Blah, blah, blah. What's the rest of this? They say that some research has been done on the placebo effect. They do give some interesting reports. This is useful to know. A beneficial effect of placebo administration has been reported in 60 to 90% of all human diseases, including musculoskeletal, respiratory, cardiac, dermatological, gastrointestinal, and nervous system disorders. I believe it's remarkably effective, the placebo effect, in gastrointestinal disorders, where being made to feel better is a large part of the solution. Anyway. Furthermore, a placebo response rate of approximately 35% is commonly cited in the medical literature, although higher rates have been reported and are most frequently seen in diseases with clinical signs that wax and wane, fluctuate, or spontaneously remit. That's a useful reference because that's describing that it can happen because of regression to the mean. Anyway, so their study, can you give dogs a placebo pill, a sugar-coated pill that doesn't do anything, and see some improvement in their symptoms when the disease is epilepsy. That's what this is about. They compiled data. So they compiled data. I'm not going to read through all of this method. You can read these guys' papers yourself if you want. Results: 34 dogs were included in the study. I'll just look at the ones. 14 in a participant evaluating novel drug therapy, and a couple of other graphs which are not important, but I think they're really easy to explain. They get these results. Here's the chart. Figure 1. Nice figure caption. Box and whisker plots of weekly seizure frequency during baseline. In other words, this is where this is regression to the mean happened. Baseline, placebo administration, and active treatment for dogs. So for section B, this is for the novel drug trial. Description of this plot. This is a good description. This is a good figure caption. You should definitely learn from this, even though not from the conclusions I think they've drawn. The central lines of the box represent the median. The upper and lower limits of the box represent the 75th and 25th percentiles. The whiskers represent the 5th to 95th percentiles. Mean results are denoted by the black box. So, in this figure B, you have a baseline period. This is when the dogs, like the dogs have just been referred by the vet and the owner, and they have some weekly seizure frequency, which is 1.5 up here or so. And then in a later period, after they've been given either the placebo treatment, a sugar-coated pill, or an actual drug, the seizure rates both decreased. I think this is simply regression to the mean. It was simply that they were referred precisely because they were having an unusually bad week or few weeks, and epilepsy being a sporadic and slightly random variable disease, it's not. I would expect dogs in both groups to improve at random. And you might expect the ones given a drug to improve a bit more, but that's given the size of the not exactly error bars, but the range of the data in these cases, it's not particularly proved that I don't think this. There's no distinction here between the placebo and the effect of the active drug. I'm sure that would be the case if you applied a t-test to them, and it's probably given the small numbers in the trials, I'm not even certain that you'd say either of those improvements are statistically significant at, say, the 5% level, but they might be. Certainly, if you just look at the mean and median rates of how ill the dogs were, they both improved, and the ones given the drug by marginally more than the placebo, but almost all of that improvement was also seen in the placebo group. So this is a good experimental design to show the drugs didn't help very much more, although they might have helped a tiny bit more than the placebo, which I would call no treatment. It's not a good plot to show that placebo treatment, quote-unquote, works, because they haven't excluded regression to the mean. They would have to recruit, in order to exclude regression to the mean, they would have to recruit dogs in a completely different way, not recruiting ones that were already very sick. They'd have to recruit large numbers before they showed any sign of being sick, and predetermine which treatment that they'd be given if they did then become sick. That's not what they did in this trial. The conclusion, so somewhere they have a conclusion about what they say they're confused as to the cause of this. I say the findings from this study are consistent with results from similar studies evaluating the placebo effect in human epilepsy. I don't think so, because in the case of animals, there definitely can't be a psychological benefit to the patient thinking they're being given a marvellous drug. They probably don't like being given a drug at all. They say in this paper, well, they think that it's likely the expectations of the owner might play a great role in the study such as this, but actually the real explanation is not what they suggest. They're wanting to say it's possible the effect observed in the present study is because of the non-specific anti-epileptic properties of the placebo, in other words, the sugar-coated pill, they suggest, but this is considered unlikely. Well, I agree it's unlikely. Rather, they admit, and this is where I think some reviewers have started to inject some sanity, it's likely the observed effect is because of what has been termed the perceived placebo effect, or a change that is observed after placebo administration that is not directly caused by the placebo. The perceived placebo effect includes any changes associated with the administration of the placebo, including the effect of time. I'm sure this is something that reviewers of the paper demanded to be put in. It is important to note that the statistical models utilised in this study do not differentiate the treatment effect from the effect of time, and consequently, the analysis performed provides a measure of multiple potential factors that could contribute to treatment response. I wouldn't say response, I would simply say change after treatment. These factors may include regression to the mean, as well as investigator bias, client bias, the potential for high level of care during the study, and improved deterrence to treatment with active medication that is being administered in addition to the placebo, blah blah blah. A regression to the mean, this is a good description, is a statistical term used to describe the fluctuations of biological variables that occur over time. And they say take the form of a sine wave around the mean. No, it doesn't have to take the form of a sine wave around the mean. There just has to be some random distribution. Some random influence on the observed variable that you're interested in. The correct description, I'm sure inserted by reviewers, epilepsy is a waxing and waning disorder, and fluctuations in seizure frequency are common over the course of the disease. Owners are most likely to seek a change in therapy for their pet when seizures are under poor control in an unusually bad month. Over the short term, improvement in the seizure frequency is probable, regardless of the treatment administered. However, this improvement is often erroneously attributed to a recently instituted change in therapy, whereas in fact it is because of an effect of time. That is a good description of regression to the mean, and that's actually what has happened, I'm sure, in this study, which says that a positive response to placebo administration can be observed in epileptic dogs. I don't agree it's a response. I agree with that paragraph I just read out, which describes this as the effect of time, the effective timing of when people sought treatment. Right, so I don't agree with the way the paper has its title, which suggests there is a placebo effect, which dogs benefit from when they are being treated for epilepsy. But if you read the paper in detail, you see that's because their description of placebo effect includes not just a psychological effect of thinking that the treatment is worthwhile, but they also include within it this concept of perceived placebo effect. And actually, why did these ill dogs get better when they were given no treatment or a treatment? Well, to a large extent, it seems to be because it's the kind of partially random phenomenon where they, on average, improve because of regression to the mean. So that's enough of that. So regression to the mean, it's distinct. It's distinct, but not totally distinct from Simpsons paradox. You could actually see it as an issue of Simpsons paradox. It's the fact that the dogs were unusually sick to start with is both causing the administration of a treatment, in one case a placebo treatment, and causing the fact that it's probable that they will have some improvement in the short term. But it's probably better to think of regression to the mean as a distinct phenomenon when you have partially random observables, and Simpson's paradox to be driven by a confounding variable that's more straightforward. And regression to the mean is a slightly more mathematical effect. Okay, that's enough of that. I want to move on to, I'll say a bit about, because there's time in this video, I'll talk a bit about Laplace.